Hello students, welcome to this series in which we try to revise one chapter in 1 hour. This is especially going to be useful for your board examinations. We've already covered the first 3 chapters of mathematics, and today we are starting with quadratic equations, the fourth chapter in NCERT textbook. Let's get started. We'll start with a quick recap. But before studying any topic, any subject, we should ask ourselves, why are we studying this? Is there any real life implication for these things that we are studying? It turns out for quadratic equations, there are many real life applications. Let us look one by one. What are those? So whenever you throw an object, like a projectile, in physics you must have noted what projectiles are. So whenever you're throwing any object, in the real world, it's going to follow a path which looks like a parabola. A parabola is represented by an equation of second order, which is quadratic equation. So if we are just looking at the motion of that projectile in two-dimensional plane, it looks like this. So we can figure out the trajectory. We can even predict where the object is going to be after a certain amount of time. That's one application of quadratics. In civil engineering, you'll find quadratics or parabolas being used everywhere. So in suspension bridges that you can see here, even in arches of big buildings, you'll see in doorways and so on. Or if you are into adventure sports and you've seen something like this, you can calculate precisely where the bike is going to land after it takes off from a ramp. Again, projectile motion. It has applications in satellite communications as well. So there is a variety of areas in which you'll find quadratic equations to be useful. Let's move on. Now that we know why are we studying this, so that it can help us figure things out around us, not just in mathematics and sciences, but also in arts and other subjects. Let's move on. So now that we have covered why, the why of quadratic equations, let's figure out what is it. What is a quadratic equation after all? All of us have studied the chapter on polynomials, and there we saw a degree 2 polynomial is called a quadratic polynomial. Quadratic equations and quadratic polynomials are actually related to each other. There's very minute difference, and what that difference is, when you equate a quadratic polynomial to be equal to something like this, when a quadratic polynomial is written and an equal to sign is written beside it and it is equated to 0, this entire thing, this entire thing is your quadratic equation. That's all. Okay, this entire thing is your quadratic equation. So the zeros of a quadratic polynomial are, you can understand those as the roots of a quadratic equation. So as zeros relate to quadratic polynomial or polynomials in general, similar relation is there between roots and equations. Okay. So if a quadratic polynomial has 2 zeros, how many roots would a quadratic equation have? 2 roots. Okay. See, sometimes roots and zeros are used interchangeably, although it's not technically precise, but still, if we are using zeros in relation to equations, we can understand that it's talking about the roots, not the zeros. Okay, zeros are used always when we're talking about polynomials, and roots, this word roots, are used when we're talking about equations. But you will see in different books, it's used interchangeably. Let's move on to understanding the standard form of a quadratic equation. Now, the standard form of a quadratic equation is this. It's given. So we arrange all the terms in order of decreasing degree. So arrange the terms in order of decreasing degree. The degree of this term is 2. The degree of this term is 1. And the constant term has a degree 0. Okay, so when you arrange the terms in decreasing order of the degree, you have the standard form of anything, okay, of any equation. So for a quadratic equation, you write the standard form of quadratic polynomial, equate it to 0, you'll have the quadratic equation. So we all recognize the coefficient of x squared. It's a here. The coefficient of x is b, and c is the constant term. Okay, this we all already know. Let's move on quickly to this previous year's question. This came just last year. Pause the video, try it for 5 minutes, and then come back and look at the solution. Let's look at the solution now. A quadratic equation whose one root is 2 and the sum of roots is 0. So we have to find the quadratic equation. We always start with the information that is given to us. And the information that is given to us is, it's one of its roots, let's call it alpha, is 2. And its other root, let the other root be beta, okay? It's given that sum of the roots is 0. That means alpha plus beta is 0. But we know that alpha is 2, so beta will be minus 2. This way, we have both the roots. If we have both the roots, isn't it easy to find out the quadratic equation? If we have the roots, this is how we write the quadratic equation. Take a look. You write x minus alpha, multiply it with x minus beta, equate it to 0, you will have the quadratic equation. Let's do this. Let's substitute the values. Let's quickly simplify. X minus 2 here, x plus 2 here. This is equal to 0. We have x squared minus 2x plus 2x will get cancelled, and minus 4. So x squared minus 4 equal to 0. That would be your answer. Okay, here's another question. This question came in 2018, and this was a 1-mark question. Try it out and then come back to look at the solution. Okay, let's look at the solution now. If x is equal to 3 is one of the roots of this quadratic equation, then we have to find the value of some constant k, which appears in the equation itself. If something is a root of quadratic equation, what happens if I substitute this value 3 in place of x? Will the LHS be equal to RHS? Think on that. Wherever you see x, if you substitute 3, you will find that the LHS becomes equal to RHS, or this entire value of this quadratic equation turns 0. So now, if we simplify this further, minus 6k minus 6 equal to 0. See, we have an equation, a linear equation in k. Here, k is the only unknown. We can figure out k very, very easily. This minus this becomes 3 minus 6k equal to 0. This gives you 3 equal to 6k. This gives you the value of k as half. Okay, I'll just move this way. Yeah, it's half. You see? So k is equal to half. That's your value. And we are done. We've got 1 mark very easily. 1 mark questions are really easy from this chapter. Okay. Here's another question, again of 2 marks. This appeared in 2012. So what are we doing, students? We're not just randomly solving any question, any previous year questions, okay? I've picked the different types of questions that have appeared in the last 10 years. The different types of questions, okay? So it might be possible that in 2008, something similar to this appeared, only the equations were changed, the values were changed. But this type of question is seen frequently. Do attempt this, try it for 5 minutes and then come back to look at the solution. All right, let's look at this solution now. If 1 is a root of both these equations, then we have to find the value of a, b, or a into b. So if 1 is the root of both of these equations, that means, and you can see that this is an equation in variable y. Yes, this is also an equation in variable y. I hope you can identify the variable here. Okay, if 1 is a root of, let's say, equation number 1, that means I can put the value of 1 in place of y and there'll be, and the equation will still satisfy. So a into 1 square plus a into 1 plus 3 equal to 0. This gives us an equation in a plus a plus 3 equal to 0. So a to a is minus 3, or the value of a comes like this. Okay, now let's try the same thing with the second equation with let's call this equation number 2. This number 1 is also a root of this equation. So we can write something like this: y square plus y plus b equal to 0. And now instead of y, you put the value 1. 1 square plus 1 plus b equal to 0. This gives the value of b as minus 2. You have the value of b, you have the value of a. Can you not figure out the value of ab? It's easy. ab is equal to minus 3 by 2 multiplied by minus 2. Minus minus gets cancelled, or minus minus becomes plus. 2 and 2 gets cancelled. You are left with this number. This is your answer. Let's move on to the next segment, where we see how to solve a quadratic equation. Now, there are multiple methods to solve it. This year, your syllabus has been rationalized, so you do not have the method of completing the square. So I have kind of left that out. Okay, but we still have two methods. One is the factorizing technique, where you split the middle term, and the other is using direct formula. So we'll look at these two methods one by one. We learned this method of factorization in chapter 2 also. So whenever you are studying or solving questions on quadratic equations, do not forget what you learned in quadratic polynomials. Okay, all the relationship between zeros and coefficients there hold true in this chapter also. Instead, we call it the relationship between roots of a quadratic equation and the coefficients of different terms, x square, x, and so on. Okay. So yeah, do remember that. So there also we learned how to factorize by splitting the middle term. The same thing we do here in order to factorize. So this is the method of factorization in which we split the middle term. Let's say we have a quadratic equation x square minus 8x plus 15 equal to 0. Here we can write all the coefficients. So coefficient of x square is 1, coefficient of x is minus 8, and the constant term is 50. These are the coefficients. We can just look at the equation and figure those out. Now, we want to split the middle term. We have to split it in a certain way so that the two numbers that we get after splitting, those two numbers, when we add those two numbers, I should get minus 8. I should get minus 8. And when I multiply those two numbers, I should get the constant term, which is 50. So if I split minus 8 as something like this, minus 3 minus 5. If I write minus 8 like this, and I have these two numbers, I've split minus 8, okay, minus 3, minus 5. If you add these two, we get minus 8, right? And if we multiply these two, we get plus 15. That's what we wanted. So We have the two numbers x square minus 8x plus 15 equal to 0. This was our original equation. Minus 8, we have split that into minus 3 and minus 5. These are the two numbers. We've seen y. Now we write this as x square minus 3x minus 5x plus 15 equal to 0. X can be taken common from this place. We get x minus 3 if I just focus on these two terms. And then I focus on the next two terms. This time, instead of x, I'll take minus 5 common. There's a reason why I took minus 5 common and not plus 5 common. Because in the bracket, I want this term only. That's why I took minus 5 common. Okay. So if I take minus 5 common, I get x here minus 3 here. This is equal to 0. Now, why did I want these two to be the same? So that I can take this term common again. So now what do? Is I take this entire term common. X minus 3. What am I left with? This one and this one. So x minus 5. And that's why x minus 3 into x minus 5 equal to 0. This is the format in which we write this equation. You can see it here. If product of two numbers is 0, let's call this number p and this is q. Okay, so if p into q is 0, can I say that one of those must be 0? They can both be 0, yes, they can both together be 0. Okay, that's one possibility. But even if one of these two is 0, that will make the product 0. And that's why we write if x minus 3 into x plus 5 is 0, that means either x minus 3 is 0 or x minus 5 is 0. Either of these will make the product 0. And that's why we say, when we solve for it, we say x minus 3 equal to 0 gives x equal to 3. Notice this word or. Either x minus 3 is 0 or x minus 5 is 0. This gives us x equal to 5. And that's why we use or. Okay. So this is the way to solve using this factorization, using the factorization technique. Here's a question which came last year in 2023. It's a 1-mark question, very easy. It will hardly take 2 or 3 minutes for you to solve. Do try this by pausing the video and then come back to look at the solution. Let's look at this solution. X square plus 3x minus 10 equal to 0. Let's write 3x in such a way so that we can take some things common. Or the other way of looking at it, that we want to split this product. This is product, right? A into B or alpha into beta, where alpha and beta are the roots of this quadratic equation. So this is the product. Let's try to write the factors of 10. So 2 into 5 gives us 10. 1 and 10 are also factors of 10. Okay, so these are some factors of 10. If I pick these two, I'll get 10, but I also have to take care of the sign. So I can either use minus 2 comma plus 5 or plus 2 comma minus 5. These pairs will give me minus 10. So which one do I choose? The first one or the second one? To help us figure that out, we are going to look at the central term here, this one. So whatever terms we choose, if we choose this or this, adding them up should give me plus 3x or plus 3. Okay, adding them up should give me plus 3, not minus 3. So if I want plus 3, then this pair is going to help me, right? Because plus 5 minus 2 will give me plus 3. Now that we've chosen the pair, we've decided how to split it. Let's quickly split it. X squared plus 5x minus 2x minus 10 equal to 0. This is our equation now. Let's take things common quickly. X plus 5 is taken common here, minus 2 is taken common here. This is equal to 0. We have x minus 2 here, x plus 5 here. This is 0. The value of x is coming out to be either 2 or minus 5. Okay, 2 or minus 5, and that's your answer.
Now, besides the factorization technique, there is one more way to solve quadratic equations, and that's using direct formula. And this is the direct formula. First, we write the quadratic equation in the standard form. It has already been written here, as you can see, where a, b, c are coefficients. Now, we use these coefficients to figure out the value of roots directly. And here's the formula to find out the roots. So x is equal to minus b plus or minus square root of b square minus 4ac upon 2a. That's the formula. Now, when you take plus, you'll get one root. And when you take minus, you'll get the other root. This formula is also known as Sridharacharya's formula, and this is obviously based on the person who found out this formula, okay, who codified the formula. Okay, moving on. So we have this previous year's question. Let's try it out and see which technique works better. So take 5 minutes and then come back to look at the solution. Okay, let's look at the solution now. So first thing first, we have to write this in the standard form. Is it already in the standard form? It seems it's already in the standard form because the terms are written in order of decreasing degree. So it's already in the standard form. And let's figure out the coefficients A, B, and C. C. Usually we denote the coefficients by the variables A, B, and C. But since A variable has already been used in the question, we'll use some other things. Okay, we'll use instead of A, B, and C, we'll use the coefficients as alpha, beta, and gamma. Let's call this as alpha. Let's call this as beta. These are coefficients, remember, not roots. And this one we'll call as gamma, just using other variables. Okay, so what will this formula turn into? Let's rewrite the formula. X is equal to minus beta plus minus under root beta square minus 4 alpha gamma upon 2 times alpha. This will be our new formula. Okay, so I've just written Sridharacharya's formula using different variables. That's all. We have to identify alpha, beta, and gamma, which is very easy to do. So alpha is the coefficient of x square, and what's that? That's 2. And beta is the coefficient of x, which is plus a. So I'll just write it a. And gamma is the coefficient of it's the constant term basically, and we have to write it along with its sign. So that's the constant term. This is gamma. Let's now substitute the values in this formula to find out the roots. Okay, so I have substituted the values and I've done some calculations and I've simplified it to this stage. If you want to further simplify, if we have to find out one root, we'll take a plus sign, and if we have to find out the second root, we'll take the minus sign. So let's say root number 1. For this, we'll take the plus sign. So minus a plus 3a upon minus a plus 3a upon 4. That's my first root. Root number 2 would be minus a minus 3a upon 4. You do the calculations, you find out the roots, and that would be your answer. Let's move on to the next question. Now, in this question, you're free to use any method. We've learned two methods. One is factorization technique, the other is using formula directly. Use any method, whatever you're comfortable in. Take 5 minutes, try to solve this, and then come back to look at the solution. So let's look at the solution now. We have a 2-digit number such that the product of its digits is 24. Okay, let's say the 2 digits are x and y. But it's not sufficient to just say that there are 2 digits in a number. So you have to specify which digit is in the tens place and which digit in the units place. I'll consider x to be in the tens place and y to be in the units place. In order to express the number as a whole, to multiply 10 to the digit which is in the tens place and 1 to the unit which is in the units place. This will give you the original number 10x plus y. If some of you are confused about this, that why don't we directly write xy as the number? So here's the thing. In mathematics, x and y are taken as variables. So if you write xy, this means x multiplied by y. Okay, so that's why we do not write it like that. That's why you have to specify that x is a 1-digit number, y is a 1-digit number, and this operation will give me the original number. Okay, I hope you know all this already. Let's move forward. What does the second statement say? If 18 is subtracted from the number, from the original number that is, the digits interchange their places. That means y comes to the tens place and x goes to the units place. We have to subtract 18 from the original number, which is this. So 10x plus y minus 18. If this happens, we get a different number in which the digits are interchanged. So that means 10y plus x. Look closely here, y has come to the tens place. That's why we are multiplying 10 with y. Okay, this is our equation. Let's quickly simplify. This will give us 9x minus 9y equal to 18. If you further simplify, you'll get x minus y equals 2. So this is one of the equations, and the other equation is obtained from the first statement, this one. A 2-digit number is such that the product of its digits is 24. So product of its digits, remember, so x into y is 24. This is given to us. We have two equations, two unknowns. We can solve for x and y. How? So there are many ways. You can use the substitution technique. Remember, you learned it in the chapter polynomials when we were studying about quadratic polynomials. So express y as 24 upon x and then substitute this value here. You will get a quadratic equation in x. You figure out the roots of that quadratic equation and you will get the answer. Okay, I'm going to leave the rest to you, and we are going to move on to the next question, which is this. Again, a previous year's question. This type of question comes repeatedly in the exam. Okay, so this question that we did, every alternate year, you'll see that this question appears in the exam. Same story for this type of question also. motorboat going upstream or downstream and so on, and we have to find the speed of either the motorboat or the stream. Try this out, attempt this for 5 minutes, and then come back to look at the solution. So let's look at the solution now. A motorboat whose speed is given in still water. Okay, so we'll just call it velocity of the boat in still water is 18 kilometers per hour. It takes 1 hour more to go 24 kilometers upstream than to return downstream to the same spot. You have to find the speed of the stream. This is the velocity of boat in still water. So let us assume that the velocity of stream is v or x. Okay, let's assume x. Velocity of the stream vx. So it is given that it takes 1 hour more to go upstream than to return downstream. So the distance is the same, right? The distance is the same and just the time is different. The time is different because the velocities, the overall, the final, the total velocities are different. So when it is going upstream, it has to go against the stream. So its effective velocity reduces. And if it is coming downstream, then these two velocities basically get added up. The boat travels faster, reaches faster. So there are two types of motions. We'll consider those separately. Upstream motion and downstream motion. We are concerned about the time it takes to go upstream and the time it takes to come downstream. Let's assume that the distance is d. Distance upstream is d, distance downstream is d. So what is the time taken? Time taken is distance upon the velocity. Can you tell me what would be the velocity if the boat is going against the flow? The velocity is going to, the effective velocity will reduce, right? So this much time will be taken if the boat is going upstream. Time downstream would be the same distance d upon this much. Okay, this time it is coming with the stream, so the velocity is going to get added. So tu and td, the relation between this is given to me in the question. Let's look at it. Even the distance d is given to us, so we are going to write 24 in place of d now. It will help us in calculating 24, 24. Okay. So tu minus td is given to us as 1 hour. So we're going to write it like this. Tu minus td is equal to 1. This is given to us. Let's substitute the values. 24 upon 18 minus x minus 24 upon 18 plus x. This is equal to 1. This is going to give us a quadratic equation in x, and then we solve for x and find out the value of x. I think you can proceed from here and solve for x and get the answer. Let's move on to the next concept, which is understanding the nature of roots. See, we've seen Sridhar Acharya's formula is this. The quantity that you see inside the square root sign, it's called discriminant and is usually denoted by capital D. Okay, it's called discriminant. We just give it a special name, that's all. Okay. Why? Because we deal with discriminant again and again to figure out the nature of roots. Think about this. If the quantity under the square root sign is positive, will you get roots? Will you get real numbers as the solution? Yes, of course, we'll get real numbers as the solution. And that is why we say that when this quantity is positive, we get real roots. Okay, we get real roots. Doesn't matter if it's a perfect square or not, we get real roots. Okay, so and they are also distinct roots. You can try it out. Let's say we have 4, which is a perfect square. We still get plus 2 and minus 2 as the two roots. Let's look at the other case. What if the quantity under the square root sign, that is this discriminant, what if this discriminant is negative? Can we find the square root of a negative number? Can we find the square root if the discriminant is negative? We can find it, but we are not going to get real numbers. Okay, we will get imaginary numbers. You'll learn about imaginary numbers in class 11, so don't worry about that right now. But we get imaginary numbers, and that's why the roots are called imaginary. When we say that the roots do not exist, we mean that real roots don't exist. In class 11, you'll get to know what is meant by imaginary roots. Okay, so for now, we'll just consider if the discriminant is negative, we can't find its solution. We can't find two distinct numbers, so there are no real roots. There are no roots for now, or we call it that the roots are imaginary. What happens if the discriminant is 0? If the discriminant is 0, it doesn't matter whether you take plus or minus. So the root will always come out to be the same. So alpha will be like minus b plus 0 upon 2, and your second root beta will be minus b minus 0 upon 2. Both calculations are going to give the same number, right? Same thing. And that's why, although the roots are real, they are equal. So that's all about the nature of roots. We quickly revise that. Let's try some questions on this. One thing to note, students, most of the questions from quadratic equations appear from this section. Try this question. This came in 2014 and it's a 4-mark question. As I said, we mostly get 4-mark, 3-mark, or maybe more, 5 marks, 6 marks questions from this section. Here's a question. Try this out. Take 5 minutes. Come back and look at the solution. Okay. So find the values of k for which this quadratic equation has equal roots. For this quadratic equation to have equal roots, the discriminant must be 0. That means b square, this thing's whole square, minus 4ac, which is 1, so I'm not going to write that, is equal to 0. K plus 1 whole square minus 4k minus 16 equal to 0. You can expand this. So this will give us k square minus 2k minus 15 equal to 0. Now you solve this and find out the value of k. Okay, I think it's easy enough to solve. 5 into 5 and 3, those are the two numbers that you should be looking at. So once you find out the value of k, then you also have to find out the roots. So k square minus 5k plus 3k minus 15 equal to 0. K is either 5 or minus 3. Okay. So we have two values of k. Take one value of k, any value, choose. Let's say if k is equal to 5. Then you find the two roots. How would you find that? Roots will be minus b plus minus under root b square minus 4ac. Now b square minus 4ac, we all know it's 0, right? We just did this to find that out. So minus b plus minus 0 upon 2a. This will give you the roots. Basically both the roots are going to be equal. Okay, now this will give you 1. This is one case we are covering. Case 2 will be if k is taken as minus 3. Then again you'll have x equal to minus b upon 2a. This would be a root. Okay, so if you do all these steps, only then you're going to fetch 4 marks. So what did we do? Let's quickly revise. Since this quadratic equation has equal roots, that means the discriminant must be 0. If the discriminant is 0, we figured out the values of k. But instead of getting one single value of k, we got two values of k. So we used one value of k to find the actual roots, because we have to do that also. And then for case 2, we use the other value of k and found out the other root also. So found out the roots when k is equal to minus 3. Okay, I think this will help you solve this completely. Let's move on to the next question. Now, as you can see, although it appeared in 2009, but it's a 6-mark question. So always expect questions that contain more marks from this section, from the nature of roots that we are studying. Take 5 minutes, try this out, and then come back to look at the solution. Okay, let's look at the solution. The first statement says, if minus 5 is a root of this quadratic equation, that means if we put x equal to minus 5, LHS will be equal to RHS. Yes. Let's try that. That will give us the value of P. 2x squared plus px minus 15 equal to 0. Let's put minus 5 in place of x. So this is 50 minus 15 equal to 5 times p. Calculate the values and we find out the value of p. Okay, and the next statement says that the second quadratic equation has equal roots. We'll use a different color. It says that the second quadratic equation, that means this, has equal roots. That means its discriminant must be 0. So from here we say that discriminant must be 0, and we write the expression for discriminant, which is b square minus 4ac has to be 0. But before we do that, it seems we'll have to convert it into the standard form first. Px square plus px plus k equal to 0. Now it is in the standard form, alright? Okay, let's write discriminant. This is b square minus 4ac. That's your discriminant, and this has to be equal to 0. Now the value of p, we know it's 7. So 49 minus 28k equal to 0, and this will give us the value of k, 49 by 28, 7 upon 4. Okay, p's value is given 7 and k's value is 7 upon 4. We are done. With this we conclude this chapter, Quadratic Equations. I'm going to upload the 5th chapter soon.